Hi everyone, myself Panu KP, working as a lecturer in Department of Electrical and Electronics Engineering, Government Polytechnic, Kushalnagar. So today in this session we'll be discussing about the brushless DC motor, the purpose of the brushless DC motor, its construction, working and as well as application. These are the various things which we're going to cover in this session, the brushless DC motor. So this is how the brushless DC motor look like. The brushless DC motor, as the name itself indicates, it's a brushless DC motor. For the motor, DC motor, we require brushes in order to input the current to the rotating armature. So without the brush, we cannot able to supply the current to the armature. Here we are removing the brushes. Then only it are working as a DC brushless DC motor. How they going to able to work without having the brush? This is the main thing no we'll be discussing in this session. This is an appearance, a cross-section view of a brushless DC motor. So you can see that poles, north pole, south pole, hmm, the various types of poles, the north pole, south pole, and directions we will be indicating in the arrows, the stator and the rotor part. Here we will be. It's a just picture overview of a brushless DC motor. So first coming with the introduction part here. hmm, A brushless DC motor is a permanent magnet electric motor which is driven by direct current, the electricity we are here. So it's a permanent magnet motor. Here you are using a magnet, the rotor you are using, no, it's a permanent magnet. Hence the name is so called as the brushless DC motor. The permanent magnet we are using this motor, it will be driven by applying an DC source. So DC current will be feeding with help of a DC current. We are able to achieve the motor action with help of the permanent magnet in this brushless DC motor. So the short notation, the brushless DC motor, the short notation we're going to BLDC, brushless DC motor. So BLDC motor employs electrical commutation with permanent magnet rotor and the stator with sequence of coil. So what I mean with this, the commutation. In a DC motor, the commutation is main thing. What do you need the commutator? The commutator serves the purpose of commutation. It converts a DC input into an AC and supplies to the armature. So this commutation process, no, we are employing. This commutation process is being eliminated and it will be performed with the help of a permanent magnet. So permanent magnet, it will be by default having a lot of flux permanently involved in that one. So it does not require any kind of supply, additional supply in order to get the flux. So the commutation process will be achieving using a permanent magnet. Here the rotor is a permanent magnet and stator. So we cannot able to rotate the rotor without help of the flux. So in order to achieve that, for the stator purpose, we are using the sequence of coil. So with the help of the sequence coil, we can able to make the rotor to change its direction and rotate. So these are the things in the BLDC. We are using the permanent magnet rotor and the stator coil to achieve the motor action. So this is the coming to the construction part of a BLDC motor. This is a picture view of an BLDC. We can see that a cross-section view, the longitudinal view, axial view, we can say this one. How the permanent magnet uh, we are using here, no, it appears like this is a permanent magnet. The permanent magnet we are using here, and the stator coils, the sequence of coil, everything will be embedded in this motor in order to get the motor action. So the first part is the stator part. BLDC motor can be constructed in configuration. Different physical configuration means depending upon the stator winding. These can be configured as single phase, two phase, or three phase. So, what I mean by different physical configuration means it's the number of phases we are using, whether it can be single phase, two phase, or three phase motor. So, here in the picture, we can able to see the stator, how the stator actually look like. It's in circular shape with poles projecting outwards. In the pole projecting outwards to which the coil is being wound with number of turns in sequence. These turns now we can categorize into sequence, into phases. It's single phase, two phase, or three phase, depending upon our application in which we are able to serve. So this is how the stator look like. Hmm. So the stator, how are we going to make the stator? The stator of BLDC motor made up of stacked steel laminations to carry the winding. So in order to make this winding, we have to provide a stack of laminated steel. Why we go behind the stack of lamination steel means if you go for core, a solid one of a steel for the projection purpose, then the AD current will be induced and it will be having a lot of reluctance. It will it's a major drawback. Hence, what we're going to do, we have the steel laminations. It will be stacked one above the other to provide these kind of structures on which we can able to provide winding. With the help of this winding, we can able to supply the current, which is in DC current. With the help of a DC current, then it will get induced, then the flux will be produced, and it helps the motor to rotate and achieve whatever the things we needed. So this is the rotor part. Hmm. So as already said, the rotor, it has to be a permanent magnet. Look, the BLDC motor incorporate a permanent magnet in the rotor. It's going to have incorporating a permanent magnet has to be there in a rotor part. Since the stator, it's an electromagnet. We are using a sequence of coils. The rotor here using a permanent magnet. So since it's a permanent magnet, then we know we does not require any kind of external source to energize this. So by default, it will be having a lot of flux because it's a permanent magnet one, the rotor is. The number of poles in the rotor can be varied from 2 to 8 pairs with alternate south north pole depending upon the application of the requirement. So the rotor having the poles, no, the pair of poles, the south pole, the north pole makes a pair. These kind of pairs of poles, it can vary from 2 poles to 8 poles depending upon the application. We can vary still furthermore the brushless DC motor depending upon the applications, the amount of torque which we require. So the poles, these are the permanent magnet. See, we can see here, no? So in order to achieve the maximum torque in the motor, the flux density of the material should be high. The density of the flux. So we are using the flux permanent magnet. So permanent magnet, while selecting the permanent magnet, no, the flux density has to be high. If the flux density is more, then we can able to get the more torque. The more the torque, then we can able to do the perform the rotation operation very easily, and the application serves the main things which we are actually desiring and looking for. So for this purpose, we are using the permanent magnet having a high flux density. The flux density has to be high. Since we are providing the slots like these things, in order to equally distribute, uniformly distribute the flux around the north and south pole. Hence, we are providing the slots in the rotor type so that we can able to achieve and control the speed of this brushless DC motor. So we are taking the permanent magnet. So permanent magnet with high flux density. So a proper magnetic material for rotor is needed to produce required magnetic field density. So magnetic field density is more and must here is the plays a vital role in brushless DC motor. It's a permanent magnet. So once the magnet has been fixed and the machine has been taken, we cannot change it again and again. Hence, while selecting the magnet, it has to be proper. So if you go for ferrite magnet, it is inexpensive and low flux density. The ferrite type magnets, no, it will be not having the much flux density which we are looking for. So we cannot go for the ferrite type of magnets, these kind of materials, ferrite materials. So hence, to achieve and to get this high flux density, we are using the rare earth alloy magnets, the commonly used for new designs, rarely alloys, earth alloys. These are naturally available resources in the earth. These are rare materials. These are alloy. Alloy means the mixtures, the mixture of materials which make a magnet more flux density. We can achieve that one. We can achieve for that material we will be using. For this, these are the new rare materials. This we call this one is combination of these called as alloy. Samarium, cobalt, samarium, cobalt, neodymium, and ferrite and boron. These four things, these four alloys, these four metals, which we combine together, the four materials, the alloy, they makes and combine together makes an alloy. Samarium, cobalt, neodymium, and ferrite and boron. These are the four things we combine together makes an alloy which gives an flux density high. With high flux density, the magnetic flux density will be high when compared to this ferrite, the ferrous materials. Hence, we are going for these kind of alloys. Next, the rotor can be constructed with different core configuration, such as the circular one with permanent magnet on the peripheral, the circular core with rectangular periphery. So the periphery which we are discussing now, see in this picture we are here the periphery. The periphery is a circular one. The circular one. We can also get rectangular shaped magnets. Not only the circular one, we can have the different shapes. Shapes can be achieved in this rotor part. So the rotor which we are selecting now here, it has to be permanent magnet and it has to give the flux density, highest flux density here. These are things which we view the brushless DC motor actually needed. The next one, it's called as photosensor or the Hall sensor. The two names are phototransistor. We can say this is the picture how it looked like. Since it's a brushless DC motor, we are not using any brush. Permanent magnet is being used. How to control the position? How it going to rotate in the sequence? For that purpose, we are using this Hall sensor or photosensor. What does this Hall sensor do? Here, the Hall sensor provides the information to synchronize the stator armature excitation with the rotor position. So the stator armature which will be exciting using a DC supply. So DC supply will be exciting. When get excited, the rotor gets keep on rotating. The position of the rotor, where the actual the rotor position is, we can able to sense using this Hall sensor or the photo sensor, or we call it as photo transistor. So with the help of this, we can able to locate the position of the rotor, where the actual rotor is. Since the commutation of BLDC motor is controlled electronically, so what will be the commutation of the BLDC? Then we are giving the DC excitation for the stator. So DC excitation has been given and the position will be controlling electronically with the help of the transistors, these phototransistors. The stator winding should be energized in sequence in order to rotate the motor. So to achieve this commutation purpose, the stator is energized in sequence so that this motor rotates in sequence, in one after the other, with the application actually desired for. Before energizing particular stator winding, acknowledgement of the rotor position is necessary. So whether we have to go to rotate the motor in clockwise direction or anti-clockwise direction, whether we have to rotate 90 degree or 180 degree or 120 degree, these are the things which we have to acknowledgement. For this position, for this purpose, we have to first thing is the rotor position, where the rotor exactly locating. This is written for this before acknowledgement. For this purpose, the Hall sensor is embedded in the stator sense, in the stator part, and it will going to sense the position of the rotor. So the Hall sensor will be embedded in the stator, which is going to sense the position of the rotor. So this is the main thing of the Hall sensor or the photo sensor. So this all are the uh, constructional part which we required for the BLDC motor, the stator, the rotor, and to make the effective operation of this we require a photo sensor or a Hall sensor. These are the things which we actually require in this BLDC. So this was the construction part. Next, let us go for the working of an BLDC. Look at the diagram. So in this diagram, we can see the phototransistor in the leftmost, with PT1, PT2, PT3 in anti-clockwise direction. I am just saying PT1. It's a phototransistor 1, phototransistor 2, phototransistor 3. With this phototransistor, we are having a cover for that one, or called the shade, the covering of the. Actually, at one time, one particular time, one phototransistor will be exposed, and remaining two. If PT1 is exposed to light, phototransistor means light, it is exposed to light, then PT2 and PT3 will be covered using a shade or a cover. Then it consists of, see, the PT1 is being connected to the transistor 1, or the thyristors 1 is the thyristor. It's a thyristor. TR1 is thyristor 1, PT2 is connected to thyristor 2, and PT3 is connected to thyristor 3, third one. So the phototransistor or the Hall sensor is been connected to the thyristors. These are the thyristor 1, 2, and 3. These three thyristors are individually being excited by the phototransistors 1, 2, and 3. The base of the thyristors is being triggered by the phototransistors. Phototransistor, what we call the entire assembly, has a Hall sensor or a phototransistors. Then the stator winding, here the stator winding, we call that one W1, W2, W3, everything I'm saying in anti-clockwise directions. Anti-clock W1 is the first winding, W2 second winding, W3 is the third winding. These are the windings. These windings, the input supply has been given excited by some DC source. DC source will be given. To energize these is energized using a thyristors. The base of the thyristors is being connected to the phototransistors. And here the P1, P2, P3 are the position of the rotor. Here we are using a permanent magnet. No, it's a rare alloy. Combinations of four things. This rare alloy having high flux density. The position of this permanent magnet rotor. Position 1, position 2, position 3. Here in this working we are using only three positions which are 120 degree apart from each other. These positions of the magnet, it has to rotate for position 1, 2, and 3. The north pole, south pole, the north pole, south pole. These things. So these, so how the rotor going to rotate with help of a DC excitation, and the position is being controlled using a Hall sensor will be discussed in this working principle. So a simple three-phase unipolar operated motor that uses optical sensor, or a phototransistor has position detector. So I already said no, the phototransistors, the PT1, PT2, PT3, we are using here in this one to control the position of the rotor. And what the thing is, the revolving shutter, what we say that the covers shutter, as the name it will say, shuts. The at a time only one phototransistor will be exposed to light, in the remaining two will be covered. The revolving transistor shutter, no, it is coupled to the rotor. The revolving shutter is coupled to the rotor. This one. Next, the three phototransistors PT1, PT2 and PT3 are placed on the end plate at 120-degree internally apart. So as we are using a three-phase unipolar stator excited winding, the phototransistor we are using here, they are 120-degree apart internally, 120-degree apart, in order to get the rotation most effective one. So the first, the working here, before we going to energize the thyristor T1, tier 1, thyristor tier 1. Here the north pole of the rotor now faces the salient pole PT2, P2 on the stator. On the stator, the phototransistor PT1 detects the light and turns the transistor TR1 on. So at present position, the north pole and the south pole, it's resting at position P2. Now the position of the north pole is at P2. The south pole, no, it's facing the P2. In this position, the vertical position is right now here in this one. At this situation, the revolving shutter, no, the revolving shutters will be covering PT2 and PT3. The only PT1 will be exposed to sunlight. The sunlight, which detects the light. When the light falls on the PT1, this transistor turns on the tier 1, the transistor tier 1. In this state, the south pole, which is created at the salient pole position P1 by electrical current flowing through the winding W1, is attracting the north pole of the rotor and to move it in direction of the arrow. So when the PT1 is exposed to sunlight, it's going to trigger the base of the thyristors. When the thyristor T1 get triggered, the DC source which we are applying to the stator winding is energizing only the W1. When W1 will be energizing, then the rotor, the north pole, just rotates in anti-clockwise and goes and rest in the position P1. Rest in the position P1. So it will be shifting in anti-clockwise direction and moving and gets and rotates towards P1 and stay there. The position of the rotor right now is in P1. It's been excited by the winding W1 through transistor TR1 through PT1. When the north pole comes to the position to the phase salient pole P1, the shutter now, which is coupled to the shaft, will shade PT1 and PT2 and will be exposing the light, and the current will flow to the TR2. Now, when the rotor and the revolving shutter, these two are coupled, it is coupled in such a way that when the position of the rotor, the north pole, when it faces, when it comes to the position P1, when the position is P1, the shutter now closes PT1 and PT3. Though the PT1 which was exposed now get closed, it covers, and now PT2, only PT2 will be exposed. Since the phototransistor PT2 is exposed to light, the light falls on the PT2, and now the thyristor T2 get triggers. Now the base current is triggering the thyristor PT2. Once the PT2 is triggered, then what will happen? The coil, the stator coil, the W2 will get energized. When it gets energized, what will happen? The position of the rotor shifts from P1 to P2. See here. So when the current flows through winding PT2 and creates the south pole of salient pole P2, the north pole of the rotor will revolve in the direction anti-clockwise direction and faces the salient pole P2. So at the salient pole P2 will be resting. So when the north pole is in upward direction in this figure, it will be downward direction when PT2 is exposed. So now when the rotor rotates, along with the rotor, the revolving shaft also rotates. Since the shaft rotates, then the light will be covering the PT2 and it will going to exposing the phototransistor P3, PT3. Since the phototransistor is exposing PT3, then again the current flows through the base to thyristor T3 and it get triggered. Now the winding W3 will get energized. So W3 will be energized. Once the W3 will get energized, the rotor will be moving in anti-clockwise direction and it will be resting in the position P3. So when the rotor rotates, again the revolving shutter will cover PT3 and PT1 will be exposed. And this action of continuously force through that. So one at a time, one phototransistor will be energized through which the thyristor will be triggering. Since the help of a thyristors, the coil, stator coil will be energizing and the rotor keep on rotating. This is how the brushless DC motor works. Without using brush, we are making the rotor to rotate on its own. And this entire commutation process will be help will be done with the help of the Hall sensor and the thyristors. This stator winding will be energized and will be brushless DC motor keep on revolving. So next the application. It's used in computer hard disk, CD drive, cordless power tools, gramophone recorder, and electric vehicles. Nowadays, which are using the electric vehicles, no electric vehicles. In these electric vehicles, the brushless DC motor we are using. It's a brushless DC motor. Since the DC motor has got a lot of disadvantages of that maintenance, the commutation, the brush, the sparking, everything takes place. We cannot use the ordinary DC motor. Hence, we go for brushless DC motor. It is maintenance free, easily available, and efficiency is high. These are the various aspects which makes it so feasible and so wide applications. Nowadays, we are everywhere using for the electric vehicles. In use brushless DC motor. So this is how a brushless DC motor works with the help of a Hall sensor. The rotor rotates to the position where it actually required. So next we go for the MC question. In brushless DC motor, the field winding is kept on. Stator, rotor can be placed anywhere or absent. It's placed on the rotor, the field winding. What do you call that one as? The permanent magnet. By electronic circuit, BLDC can be controlled for both constant and variable torque operation. Whether it's false or true, yes, it's true. We can able to control the constant and variable torque operation using electronic circuit. Since we are using in Hall sensor, the motor speed, the rotation, we can able to easily control by triggering the thyristors with the help of a photosensors. This is what is happening. Which of the following is not advantageous to BLDC motor over the conventional DC motor? Less maintenance, long life, no risk to expose or possible for RF radiations, low cost. So the solution, the answer is D, low cost. BLDC motor is costlier than ordinary motor. It's very costlier since we are using a permanent magnet here and the phototransistors and the Hall sensors, we are using all these things. This makes its cost more, and this the less maintenance, long life, no risk for sparkings, everything doesn't take place in DC brushless DC motor at all. It's easy maintenance, easy less maintenance. There is no maintenance at all. Since we are not using brush, then there is no competition at all. Hence, there is no spark. The maintenance is very less and can be used easily. So, what are the main disadvantage of this one is for the same rating of an DC motor, the cost of the brushless DC motor will be very high, huge one. This is the main disadvantage of a brushless DC motor. In BLDC motor drives module, we do not require dash SCRs, power transistor, FETs, transistors. So transistors does not require. Since we are using here the thyristors we are using, we can use SCRs and FETs. Transistors does not require. We are using advanced one and easily controlling signals than the transistors. Hence, here it does not require any transistor. Advanced power transistor components we are using in this one BLDC. In medical field with DC motor is widely used PMDC, BLDC, brushless DC cannot be determined. So the answer is second, the BLDC motors. In medical field, the brushless DC motors is using the DC motor with the brushless DC motor. So in the medical fields, we are using here, we are doing very sensors applications, industries, medical applications. The DC motor is very high. It cannot be compact. The maintenance is huge. Spark it takes place. It has to be maintained again and again. In medical fields, there are operation theaters everywhere. No, so we cannot able to go for the regular one. Hence, we go for a brushless DC motor. Construction of BLDC is exactly similar to dash conventional DC motor, induction motor, permanent magnet synchronous motor. Totally different construction. The answer is C. It's a permanent magnet synchronous motor we are using. So this brushless DC, it's a DC motor only, but it works as a synchronous motor. The entire thing looks like a DC motor, but it works as a synchronous motor. This is the beauty of the brushless DC motor. Typical BLDC does not have dash, commutation, permanent magnet, electronic control, fixed armature. The answer is the first one, commutator. So as the name itself indicates, it's a brushless DC motor. When the brushes are absent, the commutation process, which will be eliminated, we are eliminating here commutation purpose, and which we are able to achieve that purpose using an electronic controller we are using. With the help of a Hall sensor, you can able to easily check the position of the brush, check the position of the rotor, where it exactly locates and in which direction it has to be rotated. We can able to easily using the electronic computation process. BLDC can be used instead of synchronous, normal, brushed DC motor, induction motor, air motor. Answer is B, the normal brush DC motor. So instead of brushed DC motor, we can go for a brushless DC motor. We can wide applications. We can easily the DC motor, normal DC motor can be replaced using a brushless DC motor. In these applications, in devices, the hard disk, the CD drives, the positioning, the electric motors, electric vehicles. Since there, we can easily achieve this. The speed of BLDC motor can be controlled by changing input DC, changing temperature, changing wind direction can be controlled. Yeah, by input DC voltage. Answer A. The DC supply. By changing the DC supply, the speed can be varied. The more the DC supply voltage, the speed can be changed as we required. And the rotation is obviously through the help of an SCRs and thyristors. Due to low inertia, BLDC motor have dash, fast acceleration, slow acceleration, high cost and low cost. Obviously, when the inertia is very low, it will be having fast acceleration. Acceleration we can be having fast since inertia is very low. It can be easily accelerated with the help of means the motor will have less weight. Then the less weight it will be easily excited and it can be rotated in fastly. These are the things. So now Till now, we have studied about the brushless DC motor. As the name indicates, it's a brushless DC motor. Here, we are using a rotor as a permanent magnet. The stator will be excited using a DC supply, and the position of the rotor is being controlled with the help of a phototransist sensors or a Hall sensor. We call this one. We can able to rotate the motor easily in whichever direction which we require with help of this Hall sensor. So this was the brushless DC motor. These are the various uh, things which I referred, the Tereja, Wikimeta, and obviously the internet present, and the e-source content. And for videos we can go for this, and these are the team members who give me opportunity to give an introduction about this one, brushless DC motor. Thank you for giving the opportunity. Thank you everyone.